You an update of the new features, which are called supplements, which have been added to the DICOM standards over the last couple of years. And at the end, if you have any questions, I'm glad to take them and maybe relay them to the experts having done all this work. So the first slide, I would like to show you how the DICOM process works. So we have 30 different groups. These groups are modality groups like MR, CT, X-ray, ultrasound, and so on, but also a group focusing on physics, a group focusing on web interfaces, and so on. So there are a lot of different experts, vendors, user people connecting and doing the work of the DICOM standard. And here you can see 2 meetings. There's the June meeting of this year and the March meeting of this year. So this is the meeting series where all these DICOM groups get together with the base standard group. That's where I work. And we try to make sure that anything that gets into DICOM, that it conforms to the overall picture of the standard. So that's sort of the centralized loophole to get through to make it into the standard and that everything looks alike. And here you can see that the different features getting into the standard, they are at different stages of their implementation. So 20%, that sort of illustrates this is the first time we talked about it. It's been presented with an overview slide set, the early draft of the standardized text and so on. And then it goes through a couple of meetings up to 40%, where we have the first public comment phase, where the document goes out to the public to get question answered, to get feedback. Is this the right way to get it into the standard and so on? And then between 60% and 80%, we have a second voting phase that's called the letter ballot voting, where the DICOM members can vote on the content to shape it more to be in the essence of DICOM. And then when it goes up to 100%, that means this feature, this supplement, is actually incorporated into the standard. It's like 7,000 pages of the standard, and is now sort of mandatory. If you want to implement it, you have to do it this way. And then a couple of highlights on this first slide. One big direction that the DICOM standard is taking right now is to improve the web interface, the DICOM web. So one part here is to have a service where you can, as a client, you can request to get 3D MIP or MPR renderings out of an image stack, of a DICOM image stack. So there are a couple of more examples of what is happening within DICOM with the web interface further down in the slide set. Another part is the conformance statement. So within the DICOM standard, every vendor, every type of equipment, they have to deliver a conformance statement. How does this machine conform to the DICOM standard? And this has been updated, so it's now much more table-based. So it's much easier to compare different equipment from different vendors. You can just compare the tables, but also it's much more machine readable, that you can in a way extract information and do testing or do verification and so on from the conformance statement. Now the next slide is showing, and the next couple of slides, they are showing what new features have made it into the standard. So in 2022, we haven't really finished the year yet, we have 3, and then usually the years further back, we have around 4 to 6 new bigger features making it into the standard. And especially here, I would like to show that the 2nd generation radiotherapy, that's a really big piece of work that's being done in the working group for radiotherapy. And they have, from the 1st generation, they have done a complete overhaul of the radiotherapy, of the complete workflow, how the patient is modeled, how the treatment sessions and treatment scheduling and all that is set up, but also to cover new types of equipment that is being used for radiotherapy. So that's a really, really big work that's been done over many years. And then we have a lot being done in the direction of structured report and how to record dose, radiation dose information. So one example is this cone beam CT, but there are many, many other extensions where dose is the important topic. And another interesting one is prostate imaging. So this is a structured report based of the PIRAD, the medical guideline for prostate imaging, having a report sort of capturing the information that you get from following this guideline, but in a very structured way and having it in a DICOM format. So that's a really good example of connecting guidelines to the standard. And the next one is within whole slide imaging. So this is these microscopy big image stacks. These are pyramids of images. And in this case, it's possible to record annotations to the images. And that's usually machine detected and machine drawn simple graphics like regions, like circles and so on. And if you go further back in 2020 and 2019, you can see that there are a lot of stuff being done in the direction of radiotherapy. So instead of having one really, really big feature being worked upon many years, it was divided down into different parts. And these are coming over the years, and at the end, the whole second generation radiotherapy framework will be available to implement for different vendors. And you can also see that there are some further DICOM Web features that were completed in 2019. One is the redocumentation. That means that the whole documentation of all the web services within the DICOM standard, they were redocumented to much more conform to the web standards themselves, but also to be more consistent when it comes to how is error handling defined in different sections of DICOM and so on. And also another service of thumbnail generation, so that you can use the web interface to generate thumbnails and to show them for different studies and images. And now I'm going to go into a couple of examples of what are these features, what is actually implemented. The first one is a very small one, but useful. It's multi-fragment video. So before this extension to the standard, it was only possible to record a video up to 4 gigabytes. If you wanted to record something in surgery, which is much bigger, then you couldn't do it with one video. So the change, the extension is to be able to use each of these 4 gigabyte videos as a fragment and then connect them together so that you can actually record a lot bigger data sets, like up to 100 gigabytes for a medical procedure in surgery and so on. The next one is the small piece of a report. So this is an ultrasound report where you want to capture a shear wave. That is a wave where you have 90 degrees in the direction opposite of the propagation of the wave. And there you can record stiffness in different tissues like a liver or a prostate or a breast. And you can record, you can see it on the right-hand side, what kind of information, the pressure, the speed of propagation in this tissue and so on. And that's not the complete report in itself. So it's a template for a part of an ultrasound report if you want to record this kind of information. The next one is a big endeavor of how to archive an archive. So if you have a PACS system or a vendor-neutral archive, and you need to port that into a new system, or you want to merge different archives into a big repository in the hospital, then this new extension to the DICOM standard is very useful. There are 2 different ways to use this extension. And one is to generate you can remotely initiate this generation, one object, like a tree of all the information within your PACS system. So this would create a really big log of everything in there, and that could then be used to populate a new PACS system. And doing this on the side of normal clinical work is very, very important, because usually a PACS system can't be offline for porting. The hospital is still running, so you need sort of doing it with not using too much resources on the side. But some of the vendors, they complained within the standard that creating such a repository object is not the way that they do porting of archives. So there's also another interface, and that's a query retrieve interface. And then some would say, but there's also a query retrieve. There's already a query retrieve interface in DICOM, but that's not complete. So for the normal query retrieve, you could not port or migrate a complete archive. So there's a new query retrieve service for archive portation that's really complete, that you can get everything out of an archive into a new archive. So there are two possibilities within the standard to do migration of big PACS systems. The next one is the protocol for X-ray. So this was modeled after the protocol handling for CT. And the idea is that you want to manage the way you do studies in the hospital. You want to have ready templates, protocol templates of how a specific acquisition should be done in the hospital. And for X-ray, you need to set up the equipment. You need to decide what acquisition technique is going to be used, what reconstruction technique is going to be used, and all things. And these are equipment specific. So if you have from one vendor a specific X-ray machine, you would have one protocol for that type of machine. And these protocols are really good because you have sort of a definition part where you define how should this protocol be done for this study. And then you have a performed part, a recorded part. So how was it done? Was it done exactly like the protocol, or were there any deviations that anything was done in a little bit different way? But then you have it recorded, and that can be really good for quality assurance. Did we do the study the way we want to do it? But also if you have a troubleshooting together with one or more vendors, then you can look at the recorded protocol. Was everything done the way this equipment should have been set up, and so on. Another completely different area is the 3D objects and 3D printing. So other standards outside of DICOM have been incorporated. First, it was the STL standard for these 3D objects, but later on also the object file format, which includes coloring. So it's now possible to print these kind of organs, which can be really useful if you want to plan surgery, or if you want to talk with different people in the clinic or how to do something. But also if you look at the third picture there on the right, if you can have these virtual reality glasses and so on, and then discuss how we're gonna perform this procedure. So this is definitely a side track within the DICOM, but it's also really nice to have it in a standard way. Another one is waveforms. We have all the waveforms necessary to do heart studies, like ECG and so on, but now it's also been standardized to do it for the brain. So we have all these different kinds of information standardized for doing sleep research and so on. So activity in the brain, the skeletal muscles around the brain, eye movements, waveforms for sleep studies, the breathing and the patient position and so on. So all these things are now available in the standard to be recorded. And here's another interesting example, real-time video. So the idea here is to capture a lot of different video sources within the surgery room. So it can be an endoscope, it can be a head-mounted camera, It can also be different kind of monitoring equipment, generating curves and video and so on. And they are all exactly timed with a time source, so that they are in real time exactly aligned. And they are all over an IP switch. They are all going in different channels into a recording archive. And a typical example would be you perform a surgical procedure, and the patient one day, maybe 2 days later, gets really ill from the surgery, and you don't know what happened, what did we do wrong? And then you can take the recording, go to a surgery review station, and look at all the captured videos, and maybe you'll find out that something wasn't done exactly the way it should be, or that the patient had another problem or condition and so on. A second use case would be during the surgery, you want to have an assistant surgeon outside of the surgery room being able to assist, but to see exactly the same videos or the same feed as the surgeon in the room sees. So that would be two things where this is done. And as we discussed this supplement at the time, it was really interesting with an example where this assistant surgeon wasn't even in the same country. So they were performing it, I think, in Europe, and they were doing the assistance in the US, or the opposite, I don't remember. So that was really interesting that you can do real-time video across continents. And here is one brief slide just giving you the links of how to get this information from the DICOM web page. The top one is showing where do you find the current edition of the DICOM standard. There is only one DICOM standard, and that's the current one. So every time there's an update, and that's 5 times a year, there's a new current edition. So there's no versioning, there's only the one that's important. Down at the left lower side, the news, that's showing 5 times a year, the update, where you get the latest progress of things that are not yet completed in the standard. And you get this 20%, 40%, and so on, how far they are before becoming part of the standard. And usually that takes 1 year minimum to go through that process. Up to 3 years is typical time frame to get something done in DICOM. In the middle, it's this DICOM progress showing the latest updates to the standard over the last 4, 5, 6 years. So you see all the changes to the standard there. And the final link is showing all these supplements or features over the last 40 years. So you can see every change to the standard when that feature got it into the standard, and also showing the content of that feature. And finally, a slide showing what is DICOM doing together with Fire. So there are a couple of bridges to get information out of DICOM without knowing DICOM. So you can use the Fire interface. And the important one is image study, where you can retrieve a study over the Fire interface. And a typical example would be you have an EHR application using Fire to retrieve DICOM studies for a specific patient, and then using an IHE profile image display app to display these images, first showing the thumbnails over Fire, and then showing the images that you are interested in. And also, image study as a resource can be used to send images, to retrieve images between different primary care, different labs, and so on. And they can also be somewhat securely distributed with this IHE XDSI profile. A couple of more things are being worked upon right now. Image selection resource. That's where you don't want a complete study. You want to have pieces of it, frames, segments, regions, or observations, and so on. Or more information over the Fire interface regarding dose, how much radiation dose has gotten into this patient. And also a mapping between Fire as a Fire observation and DICOM structured reports. So you don't need to understand all the nitty-gritty details of a DICOM report if you use the Fire observation interface. And also the imaging ordering workflow is a bigger piece that's currently being worked upon. And I didn't do all this work. So here are some of the people who did for the last 5-6 years this stuff, and they were not alone. So they were a whole team behind each of these names. But I wanted to list them here so that if you have deeper questions or you want to connect with them, then you can do it through the secretary for DICOM with this email address at the top. That's it. Do we have any questions?
Thank you. Question for Björn? You receive so much information that you have no longer any questions? Yes?
Hello, Charles. I have one question that may be already dealt because I came a bit later, but we're currently discussing remote viewing of images in order to be able to see like pathology slides. The files themselves are huge, so how can we across Europe exchange the information, actually seeing the images in a DICOM study in a diagnostic mode, so actually remotely controlling a server that shows you the images, and then you just stream what you do over the internet in a secure way. So is there anything in the DICOM world that would cater for this?
Wow, a very good question. So, I mean,
I'm known for it.
It definitely depends on which route you would like to take. If you want to do it over the Fire way, this image study, Fire resource would be one way, but you can't really control the server.
Yeah, but you don't view things.
No, you would.
With that, you just get at the data of the study. Here, it was really viewing.
Yeah, there is no real.
So I think you have Wadu RS with some rendering capabilities. Which I believe is a way to navigate, and you can actually define a specific image and get it back to you in a JPEG format with the right window width, the right window level, so that it's ready to be displayed.
Yeah, but that's not what you want.
I know. So
slides, etc.
Right. What's there is the web interface where you can do some request to a server to render some things for you. So there you have some granularity, and that's going to be built upon to get even more capabilities. But currently, to get that level of interaction, I don't think you would be served with that part.
So there is an IHE profile called Invoke Image Display, IID. But the philosophy of the profile is really to do a web link call, so that you actually start remotely the application and have the application interact with your browser and download directly whatever is needed. Yeah. But the communication in that case between the back end and the front end is done inside the application. Yeah. And that's what most people are doing. They discover that what you need to standardize is the back end interface with the actual study and the actual data. To move the display in a remote way, if you have a standardized call to call it, that's typically all you need.
But I think the interesting part here was that you don't want to interact with just one system. You would like to interact all over the continent with many systems.
National servers where you can actually request an image, and then you can really browse through them, singing, dancing, annotations, everything, measurements. But you do it using something like a
controller,
a controller, and you just actually zoom, pan, etc. And the file itself stays there. You just send, you stream like you do with Netflix. It could be called
a lot of things to standardize to do that.
Yeah. It's really interesting.
Yeah.
We should get you into the DICOM standard.
Let's do that. Yeah.
Other questions, Alain?
I'm not a DICOM expert, but is there a link with DICOM RTV, real-time viewer? It's something that in work in France with a search team.
Yeah, that was a DICOM video, the DICOM video link. But the idea here is to make a recording of a surgery or of a display. So you actually have a multiple streams of video, data, video, all time stamped and all exchange over IP. Okay. So it's typically the technology which is used in TV studios when they got, 22 cameras plus data on the bottom of the screen and data here and data there. But that's something Björn presented with the real-time video. But it is a recording format which is standardized in DICOM, and a transmission format which is standardized by ITU and on which DICOM piggybacks. But it is not an interactive display thing. When you use the data, the interactive display is a local application that does the interactive display. Yes?
We have a question from an online participant, Alan Visintin. The order management profile scenario for DICOM radiology in Fire, is it in progress? If yes, when is it supposed to be released in IHE DICOM docs?
That's a very good question. It is in progress, and the people who gave me the information, they should answer that. So that would be these two, Jonathan Whitby and Chris Lindop. So if you can relay that question to me or directly to these people, they can then tell exactly how far down the road we are with that
It's working group 20 that is doing that in DICOM for those who navigate the numbering of the other work groups. I think I would say it's about 1/3 done. Workflow in Fire are being discussed, begin to be discussed, but it's not a science that has landed yet. So to do a workflow is not readily, easily done, but it's definitely something that people want to do, and that will happen in collaboration between DICOM and HL7.
Yeah, that was also the last input I got from Working Group 20, that they are working on it, but it's not so far down the road. Okay, thank you very much.
Thank you. Thank you, Björn.